Hello, in today's lecture we are going to see longest common subsequence problem. This is problem under the dynamic programming. This is problem under dynamic programming. In dynamic programming, as we know that I will have a set of solutions. And all solutions are optimal solutions. All solutions are optimal solutions, and I have to find out the most optimal answer. First, we'll try to understand what is largest common subsequence. Then we'll take one example and we'll learn in detail what is about that. There will be a value. That value is ABCD and second value is BD. Under that there is a string. X will be a string, that ABCD and Y equal to BD. These are the two strings, and what we have to check? We have to check the longest common subsequence. We'll start with A. In this string there is no A, so it's not possible to include A over there. There is B. In the second string there is B, so B may include in a longest common subsequence. C is here, so C is not here, so it's not possible to include C. After that there is D, and in this string there is D also. So the longest common subsequence will be BD. In longest common subsequence there is no need to have in a sequential order. But we have to check from left to right. If ABCD is the first string, second string is BD, so BD is a part of ABCD in a longest common subsequence. If I take DB, we'll check. This is A is not present, B is present, B is present here. So C is not present, D is present but onto the left side. But what is my role? When I will start checking the longest common sequence, I have to check from left to right. We'll take one example and try to understand that X equal to ABCD and Y equal to BCD. First, arrange the table. In my table, it is going to start with 0. When there is 0, all the values are going to replace with 0. So A, B, C and D. These are the values, and on the left side there will be B, there will be C, and after that there will be D. First write all 0 here. After that I will check the first value B with the first value A. Both are not equal. Then whatever the diagonal element, most diagonal element, that will be carried forward, so it will be 0. After that compare B with this B value, check both are equal. Then whatever the diagonal value, it is going to increment with 1, means 0 plus 1 equal to 1. After that check B with C, both are not equal. Then compare the diagonal element, whatever the maximum, that is going to replace. So that 0 and 1 is the maximum. After that compare B with D, both are not equal. Whatever the diagonal element, compare those diagonal element, and whatever the maximum, that is going to replace. So with that we have completed 1, 1, 1. Once we complete one alphabet with all other alphabets, then stop that, select the next alphabet, that is C. Now C compare with A, both are not equal. Then whatever the maximum with a diagonal element, that is going to replace on that place. After that, compare C with B. Both are not equal. So whatever the maximum element from the diagonal, that is going to replace so that it is 1. After that, compare C with C. Both are equal. Whenever both are equal, whatever the left diagonal element, it is going to increment by 1. So 1 plus 1 equal to 2. After that, C compare with D. Both are not equal. Whatever the diagonal element, that is going to compare, whichever is the maximum, we are going to replace that place, going to put that place. After that, when I have taken the second alphabet, I have compared with all alphabet and my task is going to finish. After that, select the third alphabet, the D. D compare with A. Both are not equal, so that whatever the diagonal element, whichever is the maximum, will be replaced here 0. After that, D compare with B. Both are not equal, so between 0 and 1 diagonal element, whichever is maximum will be replaced here, so that will be 1. After that, D compare with C. Both are not equal, so whatever the diagonal element is going to replace here, that 1 and 2 is greater, so we will write here 2. After that, D and D both are equal. Whenever both are equal, whatever the left diagonal element, that 2 plus 1 equal to 3. When equal, whatever the left diagonal element will be added with one value. 2 plus 1 equal to 3. Now we have compare BCD with ABCD, and this is my final matrix. So we will write here matrix once again to understand in detail. After that, we will try to find out what is path followed by that particular program. So we'll easily find out what are the included over there. So this is 0, 0, 1, 1, 1. This is 0, 0, 1, 2, 2. This is 0, 0, 1, 2, 3. Now whatever the maximum answer in that table, that is 3. Check where 3 is generated. Where 3 is generated first time. So as we know that 3 is generated when I have included D as alphabet. When 3 is generated, when I have included D as alphabet. So D alphabet is a part of that common subsequence. After that, come to diagonally back. Check what is the element, what is the number. Number is 2. Now we have to check when the 2 is generated first time. When the 2 is generated first time, this is the place where it is generated first time, when C and C is going to included over there, so that C will be the part of that common subsequence. After 2, come to the diagonally back. Check what is there. There is 1. Now check where 1 is generated first time on the same place. So B and B. So B will be the part of that common subsequence. Come to back. There is 0. Check where 0 is generated first time. This is the place, so that we have reached to the origin wherever we have started. So BCD will be the largest common subsequence for the given problem statement in the x equal to ABCD and y equal to BCD. So BCD will be the longest common subsequence. We'll have a quick review what we have done in this problem statement. This is largest common subsequence. This is a dynamic approach. I will have two string x equal to ABCD, y equal to BCD. I have to dictate which is the longest common subsequence. So BCD I have written on the left side, ABCD I have written on the top. I will write 0 with all the places. I will compare first value with the first value. We'll check whether both are equal. If not equal, whatever the diagonal element maximum that I have written, here both are equal. So that whatever the left diagonal element is going to increase with one value. So that 0 plus 1. So that is 1. With this we have to fill up all the table. The table we have rewritten here to understand what is the common subsequence. Whatever the greatest value, that is the 3. So when 3 is generated first time, when dd is going to included here. So d will be the common subsequence. Come to a diagonally back. This is 2. Check where 2 is generated first time. When cc is going to included. So c will be the part of that. Come diagonally back. Check where the 1 is generated first time, when bb is there. So b is included. After that come diagonally back. Check where 0 is generated. 0. Come back horizontally. 0. So this is my origin. This is my origin. So I will stop here, and this is the largest common subsequence in my given problem statement. This is all about longest common subsequence. In longest common subsequence, what will be the complexity? What will be the complexity? Complexity is nothing but whatever number here, whatever the number here, let's consider this is m numbers and these are the n numbers. Then complexity equal to O of m into n. This will be the complexity of largest common subsequence. Thank you for the listening.